see over here is 0.2 kilograms. And the bug goes back and forth down to the low point, which this dotted line represents the zero of potential energy, and up to a high point of about 10 meters. Let's call it exactly 10 meters. And here, gravity is 10, so the weight of a 0.2 kilogram bug would be 2 newtons. Now we can look at the energy of this bug, the exchange of energy as it goes back and forth, by looking at a bar graph. The off color here is the total energy. The blue is the potential energy. The green is the kinetic energy. And if we had any thermal energy generated, this would be red. There is no thermal energy generated in this simulation right now because there is no friction. Okay. I think I had this on long enough for you to answer some questions about how the potential energy and kinetic energy change back and forth as the bug makes its trip on the skate park ramp. The other graph we'll look at is the energy versus position. So the left-right position of the bug is on the x-axis. So this is essentially x equals 0 over here, and roughly x equals 15 way over here. And this shows the energy graph, the total energy, the kinetic energy again in green, and blue is the potential energy. And you should be able to answer some questions about that too. Finally, I'm going to add a little bit of track friction, and we're going to take a look at the bar graph for the energy then. I'm going to add the track friction when the bug gets to the top, and just a little bit. And here again is the kinetic energy, the potential energy, and the thermal energy generated. Notice that the thermal energy generated grows fast when the kinetic energy is fast. But up here where the thing is momentarily at rest, on either side, thermal energy doesn't change much. I'll let this go ahead. And I don't know if you can see what the ending value of thermal energy will be. But when the kinetic energy and potential energy are both 0 at the bottom of the track, I think that you can see that the total energy will have been converted into thermal energy. Thermal energy, or heat energy is sometimes called, is the random motion of the molecules of the track, of the skateboard, and eventually of the surrounding environment. Okay, I think you guys are equipped now to answer the questions on this assignment.